This video is all about the unit circle. So we're going to take all of the things we've learned about right triangles and finally put it together in the unit circle. We've talked about this in a previous video, but I just wanted to bring it back in here. For any angle t or theta, you can look at the terminal side and where it coordinates with the unit circle, and we'll call that xy, so where it intersects with the unit circle. Now, because of right triangle trigonometry, when you have that radius of 1, when you go to do opposite over hypotenuse, you end up getting that that's the sine of t, and that's going to be your y component. And then when you do adjacent over hypotenuse, you end up getting that that's the cosine of t, and that's the same as your x component. For specific right triangles, here is another graphic to make sure that you know how these angles are created and the 3 special angles to know in each quadrant. So if I want to find pi over 4, then that does make a 45, 45, 90 triangle, where these two are the same, and that x is equal to y. If you look at the intersection of those points and everything all together, you do find that that only happens when x and y are root 2 over 2. Now that is the same as 1 over root 2, 1 over root 2. This is just with the denominators rationalized so that you don't have a square root in the bottom. There's a similar outcome for a terminal angle of pi over 3, but instead of a isosceles triangle, we actually are looking at a equilateral triangle, and it just so happens that you get those 60-degree angles, and when you cut the perpendicular, like so, you get that 30, 60, 90 piece. If you look here, then we know if you have that 60-degree triangle, that the cosine would be 1 over 2, and remember that's our x, and then your sine would be root 3 over 2, and that's your y. So that's where it comes from. The other way you can think about this is if you divide all of these by 2, since it's all a similar right triangle, then you would get your radius of 1, and then you will notice that this is your x and this is your y. The 30-degree is not in the diagram, but it's the exact same triangle, just flipped, with the leg being the other way. So notice your x and your y are just flipped when we have pi over 6, or a 30-degree angle. All right, let's use this to find some trig values. So if I wanted to find the sine of 3 pi over 4, we go and find 3 pi over 4 in our unit circle, and we map that to the corresponding angle in quadrant 1. Remember that sine is your y value, so this is just root 2 over 2. Cosine of negative 120, so this would be negative 90. I would need to go another 30. And so the corresponding triangle in quadrant 1 would be this one right here at pi over 3. Well, the cosine of pi over 3 is 1/2. Now be careful, because you want to make sure that that matches here. Now, both your x and your y are negative here, so cosine in that quadrant will be -1/2. All right, this next one is the tangent of 11 pi over 6. So 11 pi over 6, if I go all the way around, I know that my reference angle is 30 degrees. This maps to the triangle right here in quadrant 1. Now let's make sure that we have our signs here correct. So tangent is sine of this angle over cosine of this angle. And we said that that's going to be equivalent to here. And another way to then write that is y over x. But in this quadrant, down here in quadrant 4, my y is negative. So let's make sure that we have that. All right, so we would then have -1/2 over √3 over 2. I would multiply by the reciprocal and get -1 over √3. If I wanted to rationalize the denominator, then I could get -√3 over 3. All right, secant of 5 pi over 6. So I'm going to redraw this down here so I don't have to keep kind of scrolling back up and forth. All right, 5 pi over 6 is going to be here. This is in quadrant 2, so my x is negative, my y is positive, and it maps to pi over 6 in quadrant 1. Now secant would be 1 over cosine. And cosine, remember, is your x. So that's going to end up giving me 1 over the negative cosine of pi over 6. I just want to make sure that I include that it's a negative x value over here. All right, so let's go to pi over 6, and that x value is √3 over 2. So when I take the reciprocal, I get here, and if I want to rationalize the denominator, then that's going to be my answer. All right, 225 degrees is right here in quadrant 3. So 225 degrees is down here. It's a 45-degree triangle. X is negative and y is negative, and then I need to map it over here. Cosecant of 225 is 1 over the sine of 225. So I'm going to be looking at my y, and so I'm going to do 1 over the negative y of a 45-degree angle. -2 over √2. Let me write that. It's 1 over -√2 over 2. And then I took the reciprocal. And then you end up getting that that's the negative square root of 2. When you simplify. All right, last one, cotangent. I'm kind of running out of room here, but that's okay. Cotangent of 11 pi over 4. Well, let's think about where 11 pi over 4 is, because it's not on here. But let's go ahead and mark it on here. Here, this 2 pi would be 8 pi's over 4. So to get to 11 pi over 4, I would just need to go 3 more pi over 4s. So it would be the same as this, like that's its coterminal angle. which means it maps to pi over 4. If I want to find cotangent of 11 pi over 4, then that's going to be cosine of 11 pi over 4 over sine of 11 pi over 4. And I'm going to say that that's equivalent to the cosine of pi over 4 over the sine of pi over 4. And in the third quadrant, let's think about this. Oh, it's right here. In the second quadrant, negative x, positive y, so cosine would be negative. Now, at pi over 4, cosine and sine are the exact same thing. So this number and this number will be the same, and I'm just left with negative 1 for my answer. All right, let's look at one more example, kind of a different type of question. Suppose that we have some real number t that has a point on the unit circle where x is positive 5/13 and p is negative 12/13. So probably somewhere here because your y is 12/13. And so this must be my terminal angle, and this must be my t. Well, if I drop this here, I should see that x is 5/13, and this is negative 12/13. And since I'm on the unit circle, this is a radius of 1. And so I could then use any of my trig ratios, knowing that this is x equals cosine t would be 5/13. Y equals sine t equals negative 12/13. Tangent of t is going to be sine over cosine. I'm going to multiply by 13/5 and get negative 12/5. Let's do secant. Well, that's just the reciprocal. Cosecant is also just the reciprocal. And then, oh, I should say of t. And then cotangent is also this reciprocal here.